let's get started. So I'm going to talk, even though it sounds like I have a very large room and most of you don't do data integration, I do data integration, so I'm going to talk a lot about it. And basically, the whole field of getting data from place to place is an old one, but it's also a very evolving one. And there's always new tools and new requirements and new patterns and new things you can do. So I'm going to do like a very short review of history where we started doing data integration and what were the problems and how we solved them and the new problems that we have. And then I'm going to start talking about those design patterns that I see as important for doing data integration in 2018. So here's the brief review of history. Basically, when I started my career, which is more or less 20 years ago, doing data engineering, although it had totally different names back then, we had data warehouses, and we spent a lot of time modeling the data. And basically, the goal is to get to entire company data from sales, marketing, finance, all of it into one huge data model. And yeah, I was told not to get out of the spotlight, so don't walk. So yeah, so it was basically a lot of meetings, how to conform to one big schema, all those different departments with different requirements. What does a customer mean? What does an order mean? How can we really agree on one thing? Lots of meetings, and every new piece of data required very wide agreement, a lot of interviews. So getting new data was a long process, and then you got data from one of your vendors in one way, you had to get it into the data warehouse the correct way. Always a lot of ETL coding, using very annoying tools. I had to use data stage quite a lot. Maybe you said there's no data engineers, so maybe you didn't do Informatica, and I envy you a lot for never doing Informatica. And because it was such a long process to get the data we needed into the data warehouse and to generate this wide agreement, every time someone asked for a new report, we were like, well, it's going to take 3 months. We don't have these 5 pieces of data that are important to get your report. It was very difficult, and even when we got reports, it took a week to generate. It took 24 hours to generate, and you're always worried, what if the daily report is going to start taking more than 24 hours to generate? That was like the nightmare. And if something went wrong and you had to restart over, the CTO will not have the numbers for the day, and that was terrible too. So we moved to Hadoop, and we had a data lake, and we saw that the data lake will save us. And even so, it was still batchy. It was much faster batches than the data warehouse, a lot cheaper, which was important. But the best part, we could just dump the data in and tell someone else to figure it out, which was fantastic. No more meetings about data models, no more very long, very annoying ingest process. We just dumped the data, and the business analysts or data scientists or whatever title these guys chose for themselves, or maybe you guys chose for yourself, as they had to figure out that field number 18 in the CSV is actually the zip code and not the age. So basically, we took the hardest part of our job and dumped it on someone else. This is called schema on read versus schema on write, where it's our job to figure stuff out. Schema on read means whoever wants the data has to figure it out. It turns out that they now highly paid data scientists had to do basically what was my job as a data engineer, and they hated it. So we had to go back to the drawing board quite a bit. And also the whole thing of getting a report, maybe even if it was every hour or every 15 minutes, it wasn't good enough. People told us, the business told us, the world is continuously changing. The world is continuously updating. Every second, a truck goes to a store, someone buys something, someone returns something, the truck with the shipment gets delayed and the store runs out of inventory. Things happen. And the business has to know about them when they happen, as they happen. We cannot wait for... The world doesn't stop at midnight every day, not anymore, not for any business, right? We're all competing with Amazons, we're competing with PayPals, we're competing with businesses that are online 24/7. We cannot pretend that we are not. So our entire world is changed into this continuous streaming world. As a side note on another thing that changed, it used to be that data warehouses was a very specialized job, and ETL was a specialized job, and we had those specialized tools like DataStage and Informatica. And because in the data lake world, just dumping the data into a big data warehouse, into a big data lake is not that much work, the role in a lot of companies kind of went away. Or if it exists only still in the world of data warehouse, but not in the new world of streaming data integration and of data lakes, and which means that it's still normally just the engineers who need the data and who cares about the data and whose application are the most data-driven are the ones who are building this new data integration tools. They are responsible to find where the data comes from, understand how to modify it, and get the data for themselves. And this has a lot to do with some trends in the industry. One of which is the fact that it seems like between the cloud and some other things that happened, a lot of jobs went away. Not with any company. Some companies still have all those roles, but in a lot of companies that I see, they don't have QA. They have developers who write unit tests and integration tests. They no longer have sysadmins because they're in the cloud, but they may have SREs that write Terraform scripts. So a lot of things kind of disappeared. So not only software ate the world, software engineers seem to have eaten the world as well. And it means that software engineers are now responsible for a lot of the data things. And because software engineers are now responsible for data, the way we manage data changed. No more informaticas in data stage, because we are software engineers, we know how to write code, we're good at writing code, and there is no reason we'll resort to point and click when it comes time to get the data. Like, it just feels really weird. And like, how do I integrate Informatica with Jenkins, with GitHubs, with all the tools that we're used to? And the other thing is that an ETL engineer typically doesn't know exactly what's going to happen to the data. He basically gets the data for people who are responsible for the app. As a software engineer, I'm responsible for my data and for my applications. That's part of the microservice revolution, right? I have a service, me and my team own the service. We own the data part of the service and the business rules part of the service and the behavior and a lot of times the UI. We own the entire thing. Definitely we own the APIs. So I may be writing a fraud detection app, and you'll ask me, what does my fraud detection app does? And well, I have to get those events from the mobile apps and from the website and from another transactional database. And I have to screen them for patterns. Maybe someone did those impossible transactions where he bought something in New York and 5 minutes the same credit card was used in Moscow. And we're looking for those patterns. We recognize them and we flag transactions as suspicious. And we write the result to Elasticsearch database. Fantastic, but this means that I'm doing ETL, right? I'm getting data out of all those data sources. I'm processing it. I'm marking some events as suspicious, and I'm writing it somewhere else. So I'm writing an app, and I'm doing ETL at the same time. Even though I think I'm an application engineer, I'm actually a data integration engineer at the same time. So I'm going to talk about the patterns that I think are useful for software engineers who find themselves also being their own ETL engineers. And I suspect that even though a lot of you did not raise your hand when I asked who is a data integration engineer, a lot of you still have to go through how do I get my data and what are good patterns of getting data from a lot of sources and bringing them together. So I'm going to talk about different ways to do that. By the way, you're listening to me because I know a bunch of stuff about Kafka. I work for Confluent, which is a company that was started by the people who invented Apache Kafka. And I spent the last 20 years, more or less, moving data around with Oracle and MySQLs and Hadoops, and now I use Kafka, and I enjoy it way more than I enjoy a lot of things that I did before. And I have a bunch of code examples. If you're starting with Kafka and you're interested, my GitHub always has interesting things. I'm on Twitter. If you have Kafka questions in 280 characters, I'm always happy to talk. A lot of my examples are from a specific client that will rename nameless, but I really, really like them. They are a large hotel chain, and I basically help them with a lot of their data integration problems. And a lot of the examples you'll see basically come out of their use case. They're obviously general. You'll see it's very general problems, but you'll see all the examples are from this hotel. So let's start with the whole streams of events thing, because I keep talking about stream processing. What do I really mean? Well, the first thing, if you do data integration and you're wondering, why is it difficult? Why am I even complaining about my job? I love my job, but it is difficult. And part of what makes it difficult is that you have so many different systems. They have a lot of data, not necessarily big data, but just a lot of data types, like the mobile app and the logs and the database and that vendor. So you have all those different things that you have to deal with, and it adds a lot of complexity. And I'm saying it looks like they're all different, but there is something in common for all of them. And the common thing that I see is that everything you have is a stream of events. An event is something that happened in the real world. It should be, when you're doing data modeling and you're wondering what is an event in my system, it should be something that you can explain to someone in your business. It should be something that he can understand. It's a customer. It's a page view. Someone view a page in your website. Everyone can understand that. It's a search. Someone in the real world searched for something. It's your hotel chain, so you have bookings. Someone booked a room, an event. You have something that happens in a database. Maybe someone changes profile, something changed properties, price change. All those are events. There are things that happen, even if they happen in a database, are still an update, an insert, a delete are still events. If you have sensors, for example, someone walks into the hotel, he books, he checks in, he goes into a room. You know how you pass your key card? That is an event. There is a sensor there. You can send the event to a database so we know when does people go in and out of the room. It's important for security. You watch the TV. You need to negotiate prices with the people who are responsible for your cable package. We're checking which are the channels that our guests view most of the time. Or if they're no longer viewing any channels because they have iPads, maybe I no longer have to pay for cable at all. Snack bars in the hotel is another very nice source of events. So you have all those things, and there are streams of events, as in the event happened, it's immutable, it happened. You cannot change the fact that it happened. Even if someone cancels his booking later, the booking happened and the cancellation happened. And the timing order is obviously very important. So we see this as a continuous chain of events. They never stop happening, and they happen one after another, or the order counts. And each event never, ever changes. Those are the core things of streams of events. And because everything is an event, it gives you a common data model that you can use to integrate everything. So you can use that to collect, process, and store all your data as streams of events. You can do this kind of stream processing. You can use stream processing on any type of data. And you can build event-driven architectures on top. And all those things are pretty much the same thing. Storing those streams of events and processing them is pretty much the same as building event-driven application. People always ask me, what's the difference between a stream processing app and an event-driven app? I have yet to find the difference, to be honest. So let's look at an example. Let's take our imaginary hotel and look at a page view event. This event where someone viewed something on my website. It looks something like that, right? It may be in JSON, maybe not. Most of my events in my life are normally in JSON. And you can see that we have all those fields with all those values. And what happens to that event after it's collected? You can do a lot of things with a page view event. You can do features like 15 other people are also looking at that specific hotel property, trying to book a room. Please book a room fast because it's selling out, right? How many of us have seen that in one of the hotel chains that we browsed in? People who looked at this kind of hotel may also be interested in the other kind of hotel. Things like promotional programs, things like A/B testing, right? Which kind of version of the website generates more booking from people who view this page? Search relevance. I searched for a hotel in Florida. Do I click on the first impression, or do I have to scroll 5 pages in? If people continuously scroll 5 pages after they searched, my search sucks. The whole point is that when I search for something, I'll find the things that I want way up in top, results number 1, 2, or 3, right? So you get all this information, and you can do really cool things with it. I'm going to give, as a specific example, the promotional programs. I don't think I'll have time for search relevance, but you'll see it. Once you download my slides, you'll see that too. It's in there. But the thing is that I only showed you one event, and you have so many applications that need this one event. Imagine what it is in a world where you have maybe 600 or 2,000 event types, and you have all different applications. You can see that 600 event types times maybe 500 applications, which is, in microservices world, it's not even crazy. Just do the math. We're talking about 3 million types of data integrations. It's insane. Nobody can really do it. You cannot maintain it. Developers spend all their time building those different pipelines. And in LinkedIn, we used to call it the data integration tax, because you knew that a certain % of your project time is going to be dedicated to how do I get my data and process it. So we need something better. And we came up with something better. Because the moment that you see that everything is a stream of events, you say, I need a system that can store stream of events, that allows me to read streams of events and write streams of events, and help me do this kind of processing. And the moment you use a central place for stream of events, you can just connect everything once. For each application, you need to write events to Kafka, you need to read events to Kafka. You don't need to integrate each application with 600 data sources and 500 other applications. So put all the streams in one place is an important pattern. So just to recap this pattern, we think that so far, we think that everything is a stream of events. We think that in order to do data integration, you need to know how to move and process those streams of events. Kafka is really, really good at storing and processing streams of events, and it brings them together to one place. So that's why when people tell me, no, I don't need Kafka, I don't have big data, you don't need big data. You just need a lot of different types of data that you need to integrate in new ways, so you want to have them in one place. It doesn't have to be big as in a lot of clicks. It has to be a lot of different types of things that happen and a lot of different applications. So just about Kafka, what makes Kafka so good at streams of events? A stream of events, which in Kafka world we also call it a log, again, things that happen one after another in order and never change. This is the core concept at the root of Kafka. Kafka is really good at storing those things. And as you write events, you always write them to the end of the log, because events happen one after another. And when you read an event, you basically read from the beginning, going forward, and you always, they are numbered. They have offsets. And when you are consuming an event, you say, OK, I consumed event number 7. Please give me event number 8. Please give me 10 more events. And you basically continue from that point forward. It means this part of what makes Kafka so scalable compared to ActiveMQ, RabbitMQ, all those older queuing processing systems, which are different than stream processing, is that they don't preserve order, and they don't expect order, which means that the consumers there, they have selectors, they can consume things in any order. Kafka enforces this order, but it also means that Kafka doesn't have to know what did they already consume. It only has to know this is the last ID. That's it. One ID per consumer, and the consumers really store it. Kafka is not very aware of that either. So you don't need to store stuff in memory until someone consumed it, which means that if you have a consumer that shuts down for 4 days, it's not going to impact Kafka performance. If you add 10,000 consumers because you have that many applications, no impact on Kafka performance, because all they do is remember the number and reach for the next thing. This is super important. This is what allowed Kafka to scale at LinkedIn and in a lot of other places. And the 10,000 apps is not even close to being an exaggeration. Now, obviously, if you have a lot of those streams, they're not going to fit in one machine. So we said, OK, you have a lot of types of events. We'll put them into different topics. And if each topic we're going to partition, so we can spread it across as many machines as we need, just in case you have big data, each one of those partitions is going to be replicated. And when you do a write, you're basically load balancing the writes based on keys or other things between all those different partitions. And then we have the concept of consumer groups that allows us to scale consumers. So if you have an application reading data from Kafka, and you have maybe 10 it needs to read data from the page view topic. You have 10 different partitions in the page view topic, so you spread it nice and wide. You can have one consumer, and it will read from all 10 partitions. Or you can have in the same application, let's say my promotions, you can have two instances of the same application, now they're going to split the work. I get 5 partitions, you get 5 partitions. Allows us to scale out very, very easily. I'll talk a bit about that in a second. So we talked about how Kafka lets you bring in all those events into one place. But this also creates an interesting problem. Because it decouples producers from consumers, because it means that if I'm writing a microservice that writes events to Kafka, I never have to even know who is going to be reading my page views. I don't have to know who they are. I don't have to talk about to them. I don't know that even if they exist or not. So it's easy to imagine that I live in a small world of my own and cause terrible damage while I'm there. So let's go to the person who wrote a booking service. He's writing bookings. Bookings have a lot of data in them, but the important thing is you have a user ID and you have a timestamp. And in the beginning, timestamps were a long number of milliseconds since 1970, and everyone who built application based on the data in that topic knew that he's getting a log, and when he created a table or created an object, he created an object based on that long, which was really nice until someone in the booking service said, I don't like milliseconds, it's hard for me to troubleshoot, it's not human readable, I have to keep translating stuff. And you know, we have a POSIX standard for dates, let me use the POSIX standards for dates. You can imagine what happened to everyone else, right? That's fairly easy. You just crashed 50 applications that you didn't even know existed because nobody told you they're consuming from your topic. And you know, that means that you need to now have a change advisory board and 4-hour meeting every week to approve of any change, and the entire company has to be there because there's all those applications that they didn't even know about. This is terrible. Last thing any of us want to do in our life. What we want to do is to realize that you guys are writing services, and between services, the API is the contract, right? And you know that the API is how services talk to each other, so you don't change it without making tests and making sure that the change is compatible and making sure that you're not going to break anyone who uses it. And you have a lot of unit tests to make sure that the APIs stay compatible. And when you're talking to each other via a stream of events, when you're writing stream processing or event-driven applications, you're doing the same thing, except that those services are talking to each other via events. So you need to have a way of making sure that the events are always, always compatible. So at Confluent, we have a schema registry, which is basically the place where we store the schema of events that we expect to see in any topic. So in the page view topic, we know what the page view is like. We create a schema, we put it in the registry, and we have serializers that are integrated with the registry. And this is a pattern that was invented at LinkedIn and a lot of companies are using. And the idea is that now, if you try to write an event that is incompatible, the serializer itself is going to know about the schema and tell you, you're trying to write an event of this type to this topic, but you know this topic only has events of the other type. And we have compatibility rules to make sure that you can, for example, add fields. That's not a big problem, or deleting fields that have defaults. So we're trying to keep you safe. And basically, the producer, the guy from the booking app, will get an exception the moment he deploys it to production. He has to work hard and do a rollback and handle this exception, but at least he didn't break anything else. And you know, if you made an incompatible change, it's kind of your fault, so you deserve to handle this error. Now, obviously, getting the error once you deploy to production, not a big deal if you roll to production 10 times a day. It is a big deal if you roll out to production 3 months later. This is another example of our serialization exception. OK, so we really want to be able to catch those errors while we're testing the system, while we're developing it. So the schema registry has a Maven plugin. And basically, while you're developing your code, you can do Maven, validate, and the schema file. And it will go to the schema registry, check what's going on in that topic, make sure that the schema that you just changed is still compatible with the old one. And if it is, you get a thumbs up. And yeah, I think I have some bad lines here. The nightly build should also use the Maven plugin to run the validation. Whatever you use for unit tests, if it's pre-commit hooks, post-commit hooks, nightly builds, merge hooks, all those kind of things, whatever you guys do, basically you can integrate it with the Maven plugin and make sure that very early in the development process, you get errors and you don't wait until the code is in production. Super important. OK, so we have events and they're all compatible and fantastic. We want to do some transformations. And the easiest transformations are the ones that you can parallelize really well. You only handle an event at a time, and therefore you can run a lot of them in parallel. You can scale it out. As an example, sometimes you have to do really trivial kind of data cleanup. So, for example, someone is trying to store credit cards, but you know what? One of our systems is actually not PCI compliant. We didn't get a certificate. We have to hide the credit card. We cannot store it. So we need to do this small transformation, and we want to do it as fast as possible, because why waste time on something so silly? Remember, as I mentioned, Kafka has very scalable consumption model. So we have app A, and it's reading data from multiple partitions. If we add more instances of app A, it will basically, as long as we have enough partitions, we can keep on adding instances, and they'll share the data. This gives us automatic scale out. It gives us automatic load balancing. It also gives us automatic failover, because if any of those instances fail, they will someone else will immediately start handling the partition. And this is amazing, and it's very easy to take advantage of it, because if your processing is truly independent, as credit card hiding is very independent, you don't care really which partition you're reading from. You see a credit card, and you change it, and you keep on going. So you don't have any state to maintain. And it means that you can really build this simple app and let Kafka help you scale it out, and you suddenly have a distributed system with very little effort put in on your side. We call this pattern Hipster stream processing, because while there's a lot of complicated stream processing frameworks, hipsters like keeping things simple. I don't know, do you have hipsters here in Paris? So in San Francisco, hipsters has this thing called fixie bikes. And there are bikes that are kept so incredibly simple that they have no gears, no free wheel, and no brakes. So basically a frame, seat, and 2 wheels. Very simple indeed, and it's fantastic. It's nice to keep things simple. San Francisco, I don't know how many of you have been there, it has hills, like very steep hills. If you have no gears and no brakes, you're going to regret every life choice you've ever made the moment you hit your first hill. Same thing with the Hipster stream processing. You can consume, make a small change, and produce with very little things to worry about, and Kafka takes care of everything until you hit joins or aggregations, because those are stateful. You care which events you got earlier. You care which partition you get the data from. This is a lot harder. And that's where you need a framework to take care of you. So don't use a big stream processing framework if all you're trying to do is something simple. And also, don't use something simple as when you need a big stream processing framework. And I'm going to show you in a second a case where this is very deceptive. And I didn't know that I need a stream processing framework until much later in the development process. But the nice thing is that very often you can do the simple thing. So a lot of the ETLing stuff, like where do I write my data, or how do I hide an event, field from an event, or how do I filter some of the events that I don't care about, or converting units, a lot of those things are very simple. A lot of the things we do in ETL are actually very simple, and they fit well into the pattern. The only interesting thing is how do we do the E and the L, the getting events and the writing events, in a very scalable manner. And for that, we have Kafka Connect, which is a pluggable part of the Kafka framework. And it basically allows you to, you can look at it in 2 ways. Either you're implementing your own connector, in which case you're basically getting a very simple API that allows you to either do a put into Kafka, so you read from another database, and all you have to do is call put and give it the event, and the framework will write it into Kafka. And it will also keep track of the last keys that you read, or the last position in a file, so you can actually kind of maintain the same offset management. And it will also take care of a lot of the scaling in and scaling out. And the same thing on the other side, reading out. So you get a very simple API from Kafka that you can implement. And it is so simple that actually from the community, we got something like 70 or more connectors of people just writing stuff for themselves, because it's quite simple. We have like 5 different Elastic connectors, because apparently it's easier to write a new one than to try to make a small modification to an existing one. People wrote Jenkins connectors and GitHub connectors and Bloomberg connectors and gazillion databases that I've never heard of. So this is, I like it when the framework makes it easy for the community to contribute. And this is a very old slide, because now we have way more connectors than that. I think we have we're around 80 now. I think Confluent wrote this one, and this one, and I think maybe one more. The rest of the 75 are pretty much from the entire world, which is, for me, amazing. Like, for me, that's the magic of open source. You write something simple, and the entire world starts doing cool stuff. The only thing I want to warn you again, the whole pattern of having a connector, Hipster processor that just consumes events, transforms them, and writes them, and scales automatically. And that's awesome, unless you need to do state management. So let's talk about how I accidentally had to do state management and what happened. So same hotel. They give me a call and say, we have an interesting requirement for marketing. We want to do a promotion. What kind of a promotion? Well, we have this new hotel down in Florida. You know, they had a new election. Hotel down in Florida is not selling very well anymore. They don't like the neighbors. And we need to do a promotion. So whenever we see a platinum member, someone who is very loyal to our hotel, search for any beach property, let's send him discount in the hotel in Florida, and maybe they'll go to Florida anyway. Sounds simple. And the nice thing about this pattern is that ever since I started talking about it, which was almost a year ago, I think, every time I show up with a customer, they seem to have or prospect or something, they seem to have a version of this. Hey, we're doing this, and we need to, our marketing asks us to do this kind of promotion. So apparently it's a very common problem to run into, and the pattern is even applicable to stuff that isn't promotions. So here's our problem. Remember the property view events that we had earlier? We basically have session ID, timestamp, loyalty ID, property ID. Loyalty ID is the user ID of members of the loyalty program. Property ID is the identifier for the hotel, which is nice. But in order for me to know that I'm going to send this email, I need to have not just the loyalty ID, I need to know if he's platinum or not, and I need to know his level. And for property ID, I need to know their location, and I need to know whether or not the property is on a beach. And there's actually a bit more. It has to be a specific property. I need to know that he's looking for a beach, but it has to be in the US. There's a few more things that rules that I have to worry about. So how do I do this? How do I go from here to there? And our first thought was basically to say, OK, we have all those page views. We write them into Kafka. We have this consumer, remember, it's Hipster stream processing. We do an enrichment, we make a decision, we write the decision to Elastic, because we have to have a record of every decision you made and why you made it. I think it's kind of legalese for pretty much everywhere. You have to keep this Elastic for like 18 years or something. Because if someone sues you, I didn't get a promotion and you're probably discriminating against me because of my skin color, you have to go and look it up and see why you actually made this decision. Super important. But then after we made a decision, we also, if we decide that we want to send a promotion, we basically produce an event to a topic, and we have a service that knows how to send the emails. All of this is fantastic. How do we enrich the data? That was the big question. And our first draft was, oh, well, we have all this data in a database. Let's just do select loyalty. We have a loyalty ID. Please give us if he's platinum and what is his level, and then another select in the location database. And then we had 11 other databases that we had to query. It looked like a good idea. It was still Hipster stream processing, so it was still very simple, except that the DBA did not like us at all. In fact, I got some threats about the continuation of my contract and the rest of my life. And the reason he didn't like us is that apparently if you're a big hotel chain, you can get basically millions of clicks per second. That can happen. Kafka has no problem handling millions of clicks per second, if it's like a few weeks before Christmas. The database, on the other hand, did not like handling millions of new queries that nobody ever told them is going to happen per second. They did not like that at all. So you have this throughput mismatch. Kafka had no problem, but we nearly DDoS'd our own database. Whoops. The other problem is that we had to query not one, but 11 databases. What do I do if one of them is unavailable? Do I just stop everything and let millions of events keep piling up? Do I put it in a retry queue? And what if the next time I retry, something else is unavailable? How do I just send an email based on incomplete information? It gets really, really challenging. And when we looked about it and thought about it a bit, we basically figured that we're kind of trying to do a join with what is essentially a table in a database. And if some of you are in the database world and you know about nested loops joins, we're basically implementing a nested loop join. So the next attempt is basically to do the same thing, but not query the database. So that's general data integration tip, because I don't know how many of you do data integration. If your DBA starts yelling at you, you put a cache between you and your database. That's the trick. It solves latency problems. It solves some of the availability problems. It's just the first trick in the book is, if the database has issues, I have a cache. No worries. I just reduced the query level by a lot. Obviously, at that point, we figured out that we basically put ourselves in the second most difficult problem in computer science. When do I invalidate the cache? So again, hotels don't move places all that often, but we did have some other rules that were changing a bit more frequently. If I query the database too frequently, the DBAs will yell at me again. If I query the databases too infrequently, I basically do my marketing promotion based on stale data, and my marketing team will not meet their ideal goals of that many new customers. So we needed to do something a bit different. What we really needed is to get the cache to update every time something changes in the database. We needed to somehow stream events from the database to the cache, so it will get updated automatically. So luckily, some of the Kafka connectors are what is called CDC connectors, change data capture, meaning they are mining the log of events at every database. At its core, there is a log of events. It can be redo log if you use Oracle, transaction log if you use SQL Server, write-ahead log if you use Postgres, bin log if you use MySQL. I think there's few more terms, but even things like Cassandra and Mongo, the craziest database in the world, they have this stream of events, this log at the core that you can read events out of and use that. So the database represents the state of things as it is right now, but every change, every insert, every update goes into this log. And if you can grab this log and put it into Kafka, you now have the entire history of your database in Kafka. And the important thing is that you can use it to update this cache inside your application. So this is kind of the core insight of this whole pattern, is that you can use change data capture connector to grab the state that you have in a database, like the current state of the world, turn it into a stream of events that is never ending and never changing, and then go back and turn it into another state that is in the cache in the application. So you kind of do a magic trick. You turn something into another thing, and then you turn it back. And that's kind of the way it looks. So over here, you have the state, which is like this user is level silver, this is platinum, this is gold. And you turn it into a stream update insert, and then you apply it on the cache. You use this update and insert to update your caching. And it sounds like it's something that should be really, really difficult, except that it's actually, there's difficulties in if you have to implement it from scratch, if you're doing this Hipster stream processing and you're trying to do it from scratch, there is a lot of problems. Because a join means that I have to maintain the state, right? I have to maintain this cache in memory. But now I have, remember, it's a distributed system. I have a lot of instances of this application. So each one of them has to maintain this cache in memory. And what if it's too big to fit into memory? Can I shard it? What if one machine crashes and I start handling those events in another machine? How do I translate the state? How do things like failover and recovery gets really, really difficult. And then you do joins. You need to make sure that the updates for the right user IDs make it to the same machines that is also handling those IDs from the page view topic. So you have to kind of make sure that those two streams of events are partitioned in exactly the same way. It gets complicated. And we have things that make it, therefore, that's when you want to have a framework. That's where you don't want to spend 3 months of your life trying to solve all those problems, especially knowing that you don't know all the problems, right? If you do it for the first time in your life, the problems that you know are going to be the problems. The problems that I'm listing here on the board are the easy ones because I know they exist. It's the problems that you don't know that exist that is totally going to bite you in the ass. So that's where we like frameworks, and I like Kafka Streams as a framework because it has the concept of table built in, the concept of join built in. And Kafka Streams uses RocksDB as a cache behind the scenes. We love RocksDB. It was invented at Facebook. Until recently, it had a very scary license, but they made you agree that if you use it, you'll never sue Facebook. But they removed this clause, fortunately. And maybe all the current legal trouble are all because they removed this clause and suddenly people start suing them. I don't know. But anyway, they fixed all these license issues. And we love RocksDB because it's a very fast database. And it stores everything in memory until it cannot. So we get a lot of the benefits of memory access. And we don't have any of the drawbacks of having to deal with garbage collection. Every time we find something that means that we don't have to deal that much with garbage collection, my life gets a lot better. That's as a rule. So we basically use the RocksDB as the embedded cache in everything that I told you about. And we use Kafka itself as a place where we maintain all the changes that happen to that cache. So if we lose an entire machine and we have to recreate it, we recreate it from the topic in Kafka. So it's very nice. And again, all this behind the scenes, all you have to do is create a table and do a left join with KSQL, which is a new SQL language for querying Kafka. It basically makes it even easier because you can do select from page views. You want the loyalty ID, the username and email, join with the loyalty table, join with the profile table, and where loyalty level equals platinum, where location equals Florida, all these things. And basically, if you want to see how to do it, we have a big example showing you all the details with the code, and you can just walk yourself through that. So I mentioned earlier that I have some content regarding how to join streams in order to know about your search efficiency, but I have 3 minutes and there's no way I'll be able to do it. So the slides are there. Just grab the slides and go walk yourself over that. We went through a bunch of patterns, though. Leaving aside the things we didn't get to do, we got to do a bunch of stuff. We talked about how to model everything in the world as a stream of events. We talked about how important it is to make sure that the events are compatible, so a producer cannot cause untold damage to all those consumers and force you into a 4-hour meeting every week. Been there? Don't go there. Terrible. We talked about when is it efficient to do Hipster stream processing and when it is actually not such a good idea. And we talked about a problem that started out like it's simple and I can do Hipster stream processing, and then suddenly I had a cache and I had to maintain my state, and Hipster stream processing was no longer a good idea. So thanks to everything. I have like 2 minutes, so I can probably answer a question. Yes. So first of all, I recommend using a schema. Sorry, the question is, do I have to use a schema registry or could I use something else? We like the schema registry. We think Confluent registry is not even the only one. A lot of people use that, so I think it gives you benefits. You don't have to use it. And if you think you have another solution, Kafka doesn't care about what data goes in. Kafka doesn't care if your applications break. So you can use whatever you want. Kafka will still like you. Make sure that you are safe so your producers cannot break your consumers. That's it. Yes?
You're saying that you embedded the rules in the Kafka, the business rules in Kafka.
You can actually do, yes, business rules in Kafka.
Is it possible to decorrelate the rules out of Kafka?
Yeah, so you can do a lot of things. So he asked about business rules in Kafka, and that's an awesome question because there is so many ways to do it. And one of my favorites, a lot of people use rules in their Kafka application to store their rules. I've seen people who have a rules topic in Kafka where they store Scala snippets that they can then execute on the fly. So if there's a rule change, you just publish a new code snippet, the consumer consumes it and executes it. Obviously, do it only in a very trusted environment. I've seen people who write UIs, like open a REST port and allow people to submit new rules via REST, and they wrote the rules using JavaScript and used Rhino to have Java execute the new rules. It's just an application. That's the whole thing. So there is so much different ways you can do rule management. You don't hard code it. Like that's not the right takeaway from my example. Guys, we totally ran out of time. Thank you, everyone, for being here. It was awesome.